Okay, picture this. You're running late. We've all been there, right? You whip out your phone, tap Share Live Location on WhatsApp, and boom, instantly your friend sees that little blue dot, your blue dot, just gliding across their screen in real time. They can see every turn you make, every red light you're stuck at. It just works. It feels so seamless, it's almost, well, it's kind of like magic.
But how? I mean, really, how does that work? How is your exact position beamed literally across the world in just milliseconds? And maybe more importantly, how does it all stay private? The answer isn't some shady backdoor or, some kind of digital sorcery. It's actually something way more interesting and honestly, a lot more impressive.
Yeah, it's not magic. What's happening behind that simple blue dot is, well, it's a masterclass in systems engineering. It's this incredible dance between satellites, super fast private networks, and some seriously clever cryptography. So, come on, let's pull back the curtain and see how they actually pull this whole thing off.
All right, first things first, let's tackle the blue dot mystery. Before we can send your location anywhere, your phone has to know exactly where it is, right? And the answer to that? Well, it starts thousands and thousands of kilometers straight up.
20,000 kilometers. That's how high up the GPS satellites are that your phone is talking to, like right now. It's constantly listening for tiny little timestamps from at least 4 of these satellites. Then it does some quick math on the delay, and from that it triangulates its and yours precise location on the planet. It is literally space-age technology just sitting right there in your pocket.
But here's the thing. Getting a lock on those satellites from a cold start, that can take a whole minute. And in the world of live location, a minute is an eternity. So here's the first clever hack, something called AGPS, or Assisted GPS. Your phone basically uses the internet to get a little cheat sheet. It tells it exactly where to look for those satellites before it even starts searching. And just like that, the connection time plummets from 60 seconds to under 10. So much faster.
Okay, so that's great for when you're outside, but what about when you walk indoors? You lose sight of the satellites, right? So what happens then? Well, the system is smart. It doesn't just give up. It just switches gears and starts triangulating your position using nearby Wi-Fi networks and cell towers instead. The accuracy might dip a little bit, sure, but it's enough to keep that blue dot moving and on the map.
And check this out. This is one of those little details that just shows how deep the engineering goes. To stop your battery from completely draining, the system uses something called adaptive polling. It's so simple but so smart. If you're zooming down the highway, it updates like crazy. But if you're just standing still, maybe waiting for a coffee, it chills out and slows the updates way down. That saves a ton of precious battery life.
Okay, so now your phone knows exactly where it is. That's part 1. Part 2 is the really big challenge. How do you get that info from your phone to your friend's phone across the world instantly? And I mean instantly, without it getting bogged down in all the regular internet traffic. Well, the secret sauce here is something called edge computing. See, instead of sending your location data on a long-haul flight all the way to some central HQ, probably in California, your phone just sends it to the closest meta server. They call it an edge node. The analogy is perfect. It's like having a local manager handle your issue right there, on the spot, instead of having to call the head office for every little thing. And the difference this makes? It's not small, it is huge. Sending that data all the way to a central server could take over 100 milliseconds, but by hitting that nearby edge node first, the time gets slashed to somewhere between just 10 and 50 milliseconds. That is a massive, massive shortcut in the digital world.
So let's trace the data's secret journey. It's a 3-step dance. Step 1, your phone zaps the data to that nearest edge node. Step 2, it jumps onto Meta's own private fiber network. You can think of this like a secret internet superhighway completely bypassing all the normal traffic jams. And finally, step 3, from there the update is broadcast or fanned out to all your friends in the chat at the exact same time.
And the result of all this? The entire journey from your phone across the world to your friend's screen takes less than 100 milliseconds. To put that in perspective, that is literally faster than you can blink. It's just incredible.
Okay, so we've got precision, we've got insane speed, but now we need to talk about what might be the most important piece of this entire puzzle: privacy. How on earth does WhatsApp make sure that the only people who can see that little blue dot are the people you want to see it?
And this part is absolutely crucial. It is non-negotiable. Every single update, every ping, every little coordinate that gets sent is locked down with end-to-end encryption. Let me be clear what that means. WhatsApp can't see your location. Meta can't see your location. The only person on the planet who can decrypt it and see where you are is the friend you chose to share it with. Period.
But wait, it gets even better than that. The system uses this brilliant idea called forward secrecy. Okay, think about it like this. Every single location update you send gets its own unique key, a brand new one every time. And as soon as that update is sent, the key is basically shredded and thrown away forever. So what does that mean? It means even if a super hacker managed to steal your current key, all your past locations would still be perfectly safe. They can't go back in time.
Here's a great way to think about it. Meta servers are just the delivery service. It's like the quote says, it's like FedEx not reading your letter, they just read the address. The servers can see the digital address on the outside of the data packet so they know where to send it, but because of that encryption, they have absolutely zero ability to open the envelope and read the letter, your actual location inside.
All right, so we've seen how brilliant all this engineering is, but, it's not perfect. Nothing ever is. At the end of the day, all this amazing tech has to exist and work in the messy, unpredictable real world.
So, here are the gotchas, the real-world trade-offs. For one, fake GPS apps can totally fool the system. And that constant updating? It's a killer for your battery. We're talking up to 20% an hour, which is a lot. If you've got a weak signal, you'll see your little dot jump all over the place. But really, the biggest catch has nothing to do with technology. It's us. The system can protect your data with all this fancy encryption, but it can't protect you from yourself if you choose to share it with someone you shouldn't trust.
So when you take a step back and look at the whole picture, it really is a masterclass, isn't it? You've got satellites and AGPS working together for pinpoint precision. You've got edge computing and private networks delivering that information at incredible speeds. And you have forward secrecy and end-to-end encryption giving you that uncompromising, rock-solid privacy. It's the whole package.
All of these pieces come together to create a feature that, yet it really does feel like magic. But now we know it's not. It's just a beautiful, complex, and incredibly elegant system built by some very smart people. And it kind of makes you wonder, doesn't it? What other magic that we use every single day is really just another masterclass in engineering, hiding in plain sight?